Okay. Where was it just now? Okay, using the pure matrix, you get the result, right? If you use the plus, minus, and equal signs, yes, you can get which one is the highest, and you can see which one is the lowest. But I would say that method is not really um, complete, in the sense that it's just telling you what is best, what is the second best, and etc. But it doesn't give you or allow you to get something that is the best. What I mean the best is you gain profit at the same time you minimize the rates of getting that profit. Okay, the disadvantages of Topsis is it is dependent on cardinal information. Of course, the weightage, because weightage is the things that weightage is the values that we assign or you assign. Okay, I'm very sorry for Muadi's keep on request to join, but it doesn't work. I hope. Okay, weightage, and the solution highly dependent on values, accuracy of the prediction for the evaluated concept. Okay, of course you have to meet the criteria to have a monotonically increasing or decreasing utility to the decision maker. Okay. Okay, there are a few steps. I would say depend on where you start. Okay, depend on where your starting point at that particular time. Sometimes you just need 5 steps. Sometimes it can go up to 7 steps. Okay, but anyway, the process is like this procedure. First, we need to create a decision matrix, just as the one that we have done using the pure evaluation matrix. Okay, mapping the alternative and the evaluation criteria like we have the last 2 weeks. And then we need to quantify qualitative criteria using an interval or scale. For example, you say that it is for concept one, for example, concept one, you said it is cheap. And concept number 2, you said cheap and then cheaper. Concept number 3, you say that it is expensive. So those words, you need to put it into numbers. You need to change it into numbers. Okay, you need to have a you need to put a quantity. Okay, and then the next step is for each numbers we need to normalize it. Okay, what does it mean by normalize is we it is a scaling, we normalize based on the total value, I would say like that. But I think we need to go through examples to look into it. Okay, and then we need to multiply with the weightage values that you assign, and then group the positive and the negative ideal solution. Okay, this is very important. Group the positive and ideal solution so that the next step you can calculate you can calculate the separation distance for each alternative. Okay. Next, to calculate the relative closeness rating, and finally, rank each of the alternative. Okay. The main difference between these Topsis and Pube matrix is that using Pube matrix, we are going to have a datum, right? But using Topsis, we don't need to have a datum. Okay, we evaluate each of it, no datum involved, and also you don't need to have since you don't have datum, which means that you also uh, don't need the what do you call it uh, what do you call it just a second, the comparison. Can't. The one that you get from the competitor, what do you call it? Can anybody help me that?
Benchmarking, okay?
Yeah, benchmarking. Yeah.
Benchmarking.
Yeah. You don't have anything to benchmark, okay? Because we don't have data. Thank you. Thank you, IZ. Okay, next. Okay, this is the most important part. Okay. For tonight, okay, I will go through the lecture only. And if I will ask you guys if you feel that you are okay, because it is quite the math is quite involved. If you feel okay, then we can proceed. Okay, because normally during class it took me like more than 2 hours to look into this and to make sure that each of you understand it. Okay, first create the matrix, decision matrix. A slash C here, what does it mean is the aircraft. Okay, aircraft. Normally, in our normal case, what we did is the criteria on top here, okay? Speed, range, payload, cost, reliability, and maneuverability. We put it on the first column, am I right? Okay, normally we put it on the first column. And the concept 1, concept 2, concept 3 is on this top here, right? But now I change it, okay? Because we want to save the space. Okay, that's the only reason. Actually, you can have a criteria on the top or on the first column. This doesn't matter. Okay, no problem. You can interchange. You can have your concept up here or your option, your concept or option, like this one. Aircraft 1, aircraft 2, aircraft 3, aircraft number 4. Okay, on the second column here, we have a speed. Here, I think it is mentioned in the Mach number. Mach number is a representation of a speed relative to the speed of sound at certain altitude. Okay, speed of sound. Just an additional info for you guys. Speed of sound at sea level, at certain density, temperature, etc., normal condition, is around 340 meter per second. If you want to convert into kilometer per hour, you need to multiply by 3.6. Okay, just to give you an idea, what does it mean, the value. Okay, 2 means twice the speed of sound. Simply as that.
It seems a supersonic aircraft, Prof.
Yeah. Okay. So anything, if it is below 1, just below 1, we call it transonic, like, okay, like 0.7, 0.8, 0.9. That is the range of commercial aircraft, because normally we travel with aircraft, right? The cruising speed for an aircraft is around 0.9, 0.85, 0.9, something like that. It doesn't go beyond 1.0. Okay, just under the speed of sound for commercial aircraft, because that is the design of that particular aircraft. If it go beyond that, then the structure might have problems, vibration, the engine have choke, the wing might stall, and etc. Okay, there is the limitation for that particular aircraft. And these numbers here represent that each of these aircraft is seems like supersonic aircraft, of course, jet fighter, I would say. Okay, and the range on the third column here, range, it is 1,500, 2,000. It is normally represented in nautical mile. Okay, for aircraft, normally we put it in nautical mile. And payload, you can see 20,000, 18,000, 21,000, and 20,000. And it is normally in pound, British unit normally. Okay, and cost 5.5, 6.5. I have no ideas which currency that they are using or refer to. Okay, I think it's just numbers. And reliability, of course, they put words, so we need to change it into numbers after this. Like this one, maneuverability very high. Very high means the aircraft can turn quickly. Okay, average mean it can turn but not as quick as very high, like this one. Okay, okay, step number 2, enough on this step number 1, but down here you can see that from the speed, range, payload, and cost, all these mentioned in numbers, so it is objective. And on the last 2 column here, it is mentioned in words, okay, to represent their characteristics. So it is a subjective. So we need to make it more objective. So we need to change it into numbers. And you can see down here, step number 2, the numbers are the same for column number 2, 3, 4, and 5. However, the last 2 column here, since the previous one it is in words, so we need to change into numbers. And I believe it is rating from 1 to 10, and average is of course 5. Okay, and then low is 3, high is 7, and average is 5 again. And very high is rating at 9, and the rest is follows. Average 5, high 7, and average is 5. So this is the, now we have everything in, we have numbers, so we can quantify. Okay, okay, done with step number 2. Any questions so far? Okay, everybody can follow.
Yes, bro. Yes, can doctor.
Yeah. Okay, step number 3. Yeah. We need to uh, do a little bit of math. Okay, we need to dimensionalize. Okay, how we do it is, okay, Okay, I need the previous. Okay, just a second. Just a second. Put it there. Okay, how we do it? You can see that on this particular box here, initially it was 2.2, right? Now, what you need to do is 2.2, you have to divide with the total of this column, okay? Which means 2.2 divided by square root of 2 square plus 2.5 square plus 1.8 square plus 2.2 square, and it is the result. And you need to do it for each of the box here, for all of it, okay? And be careful that, okay, the denominator down here, numerator or denominator, but anyway, the things down here must be from the same column, okay? You can, if you want to calculate for this particular box here, okay, so you can use this value. For this one, 0. To get this 0.4671, you have to 2.0 divide by all these numbers, okay? However, I need to use my
Doctor,
yes.
just a question again. I mean like apa tu? I terlepas sekejap tadi. I mean like not the down there 2.2 over, yeah, that one, the 2.2 there.
Okay.
Yes, that one. Where do we get that one? Is it a fixed number or?
Okay, how do we get this one, right? Okay, first we have to look. This is from the previous, okay? This is from here. I copy this one. So I put it top here. Okay, I put it
Okay.
here. Okay. Now, to calculate the normalized value on this particular box, to get this one, 0.5139. So what you need to do is 2.2 divide by all this square, this one square, this 1.8 square, 2.2.
Oh, so if we want to find for 1.8, so 1.8 divide with everything there also,
Yes.
square.
Okay, if any numbers from this particular column, you can use these values. However, if you you want to calculate for next column, this one or this one, you have to divide by the total of that particular column. Okay, for example, like this one, right? To get the normalized value of 1,500 on this part, what you need to do is 1,500, okay, divide by 1,500 square plus 2,700 square plus 2,000 square plus 1,800 square, and then everything is square root lah. Then you get this 0.3662. Okay. Okay.
Same concept to like payload, cost, reliability, and maneuverability.
Yes. You have to divide by the respective column, the numbers that you get from the respective column lah. Okay, you cannot use this value for any column. No, this particular value down here is only applicable for speed. Okay, clear?
All right, clear, sir.
Okay, I proceed to the next part. Okay, next is we want to assign a weightage value. Okay, weightage value, I think this is not the first time that we talk about weightage value. And the weightage value must be, the total of the weightage value must equal to 1.0. For example, this one. The weightage value for speed, I put it as 0.2, range is 0.1, payload is 0.1, cost is 0.1, reliability is 0.2, and the last one, maneuverability, is 0.3. If you total 0.2, 0.1, 0.1, 0.1, 0.2, and 0.3, they are equal to 1.0. Okay, you can put any numbers. Okay, you want to put 0.25 or 0.1 or whatever numbers, but make sure that everything equal to 1.0. Okay, clear on that? Huh? And these particular numbers is depend on how important that particular part for you. For example, the most critical component for this particular aircraft, okay, AC stand for aircraft, is maneuverability. Okay, the most important. And what not really important is range, payload, and cost. Okay, range, payload, and cost. So range, payload, and cost just 0.1 for each of these three. And what you need to do is, just a second.
Doctor,
Yes.
before moving to slide step 4, I would like to ask you what does it mean by non-dimensionalized? In step 3, it is stated non-dimensionalized. Yes, up there, non-dimensionalized.
Mm.
Is it we give a numbers to the attributes?
Basically, we want to get rid of, for example, I don't want to explain in the maths way, but I want to explain in the layman words. Okay? Put this way, if you see here, the value here is only 2, but then on the next column, it is 1,500. You see? And the next column is 20,000.
20,000.
So it is not it's not fair, for example. It is not fair. Okay? The simple words I want to put it. It is not fair. So we want to make a fair evaluation.
So
We want
they
to
are not
see, yeah, we want to see numbers
proportionate.
that is
Okay.
on the same page for each column.
Okay.
Here you can see that yeah, they are not far away from each other. So that is sort of idea of having this step number 3. Okay, clear?
All right, clear.
Okay.
Thanks, Radha.
Yeah. Moving on. Step number 4. Just now we have normalized the values. Okay. And then the next thing is we want to multiply with the weightage value that we have assigned. Okay, for speed, it is 0.2. Sorry, I need to put it up a little bit. Okay. Okay, for the speed, it is 0.2. So, and which means 0.4671, you need to multiply by 0.2. Then this is the value that you are going to get. Okay, 0.0934, and you do it again for the next, and again for the next, and again for the last one here. And this is actually 0.5139. It is here, the same value. You just multiply by the weightage value for that particular column. Okay, remember? Yes.
Doctor, can
Yes.
you explain to us again about the where we can get the weightage value? I mean, it's like 0.2, the 0.1, 0.1, 0.1. How can
Okay,
we
okay,
determine? I mean, it's
okay,
like it
okay.
says from the QFD, right? I mean,
Yeah,
like,
yeah.
then how can we determine which one is 0.1, 0.2?
Okay, not really QFD, but we go further backwards. Okay. Remember that you have done the Pareto, right, last time? And even from
Yes.
the Pareto, you can see that which one you have to prioritize. And then after we have done the Pareto, we move on to the QFD to see uh, in a more broad picture, because with QFD you can also compare with competitor. You can check their each engineering parameters, and you can calculate from many point of view, right? So from there, from the result of QFD down below, you can decide. Okay, you can decide what value, what weightage value that is suitable to represent uh, your criteria, your item. For example, one of your criteria is, can you name any criteria from your QFD? Just anything.
Size.
Size, for example, right? So size. So is that size is really important in your design? If it is very important, then you should put higher value of weightage value.
So the higher means like 0.3, something like that. Zero.
Yeah.
Or
Any number, any number.
oh, so it doesn't fix on 0.3,
No, 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 no,
0.4,
no,
0.1.
no, no, no. You can put 0.25, 0.3, 0. Any numbers.
So if we
Any
just give
number.
like 1, 2, 3, 4, 5 also can, something like that.
No,
Or is it must be
no.
0 point something?
Yes, 0 point something. Okay.
Okay.
Because of you need to remember that if you add them together, all weightage value, you add them, they must equal to 1.0. Okay, that you have to remember. Okay, the total weightage value must equal to 1.0. That you have to always keep in mind. But numbers is up to you. QFD will help you. Okay, will help you to determine, to
So it depend on us to distribute it, but
yes,
then
total must equal to 1.0.
okay, so means like the more we have the criteria,
Yes,
so the more we must like distribute it evenly lah, something like that.
yes.
Not evenly, it means like
The weightage. weightage should be higher. If
Okay, got
that,
it.
okay, clear. Okay, then again, the weightage value must be multiplied for each individual box on that particular column. In this case, for speed, it is multiplied by 0.2. So everything in this column for speed, you have to multiply by 0.2 to get all these numbers. For range, you have to multiply by 0.1. Then you get these numbers, and etc., etc., etc. Okay. Similarly, for the maneuverability, you have to multiply this column with 0.3 to get all these values. Okay, clear? Any question? Shall I proceed? Okay. Next. Okay, I need to copy that again. Okay, anyway, the step number 5, we need to establish the ideal actually this one is a positive ideal. Okay, we need to establish the positive ideal and negative ideal solution. Determine if the attribute are benefit or a cost. Okay, benefit is does it good for you, or cost mean does it bad for you. Okay, okay, benefit are to be maximized. Okay, it is a good thing. Benefit, we want to maximize it, and cost, which means the bad things, we want to minimize. Normally cost is the one that we want to minimize, but sometimes on certain design we want to also reduce the size. For example, size could be a thing that we want to minimize. We want to design something that is compact, right? So if the design is bigger, then we should minimize it. Same goes to if the design is heavy, we want to make it more, we want to reduce the weight, then weight is the thing that we are going to minimize. So it depends on case by case. Normally for aircraft, what we want to maximize is, of course, the speed. We want to increase the speed, increase the payload, range, reliability, and maneuverability. And the thing that we want to really minimize is the cost, because it is from the taxpayer normally, right? Okay, because for it is not a commercial aircraft, it is a jet fighter aircraft, so the government have to pay. Actually, our pocket. Okay, positive ideal solution where we got this number, and also this negative ideal solution. The number we got it from here. Okay. Okay. 0.1168 is from here. So if you look for this particular column, you look column by column, or criteria by criteria, because here the highest is 0.1168. Okay, we are looking at the highest because we are talking about the positive ideal solution, the highest. So for speed, the highest is 0.1168. So we put it there. For the range, the highest is 0.0659. And this one, for the payload, the highest is 0.0531. Okay. And then for the cost, okay, this is interesting. For the cost, because we want to get the positive ideal solution, for the cost, we know that lower number is better, right? For cost, okay, lower number is better. So that's why we, on this particular column, we pick the lowest value, 0.0414. Okay, we didn't pick the highest value. We pick the lowest value because lowest value represent a positive things for us because it is cheaper. Okay. Then for reliability,
So, Doctor,
yes,
so I can say it seems goes to the fuel consumptions, the weight of the aircraft,
yes, yes,
perhaps.
yes.
Okay, great, great.
Okay, that's correct. And then reliability and maneuverability, we pick the highest value because this is the thing that we want to maximize. Okay. And then for negative ideal solution, we do the reverse. Okay, just now we pick the highest value. Okay, but now it is negative, so we pick the lowest value. The lowest value for the speed is 0.0841. And for the range, the lowest is 0.0366. For payload, it is 0.0455. And then for the cost, since it is a negative, negative means we pick the highest value. The highest value here is 0.0598. Okay, this one. And then for reliability and maneuverability, we pick the lowest value. Okay, 0.0577, and for the maneuverability, it is 0.1118. Okay, if you notice for this maneuverability, the lowest value here are the same, 0.1118. There is repeat on this one, 0.118 down here. So the same value. Does it? No problem. Pick any of the value. Sometimes you repeat 3 times or 4 times. No problem. If you need to pick the one that is the highest, then pick the highest. If you need to pick the lowest value, then pick the lowest value. Okay. Sometimes it is the numbers are repeating, so no worries. Okay. Oh, one thing that I forgot to mention, when we do the normalize process, I think on the step number 2 or number 3, if I'm not mistaken, we normalize the
Number 3.
number 3, yeah. Okay, this one we normalize. You notice that if let's say there are values that is negative values, okay, sometimes there will be a negative value. Okay, when we do this process, what happen is eventually sorry, not doesn't work. Okay, never mind. Sorry, I made mistakes. Okay, do you have any question on the positive ideal solution and negative ideal solution so far? Do you understand how to get these values and this one?
Yes, it's clear, Doctor.
Okay, clear. Okay, step number 6. Okay, 2 more steps. Step number 6, and later on we have the last step. Okay, step number 6. Calculate the separation distance. Okay, this is the value. This one, the value. Actually, this should be plus. Star here should be plus. plus slash minus. Okay, this one also plus actually. I think that we have a problem to type pluses at that time. Okay. Anyway, how to calculate this one? Okay, the process is like this. Let me take one example from this one. Okay, to calculate the separation distance, okay, S1 plus here, and down here we have S1 negative, right? There is positive, there is negative. So what does it mean is actually, earlier we have discussed that we want to get rid of the risk, and also we want to get the maximum profit that we can get. Okay, so this is sort of representation values that uh, for us to foresee the positive solution and the negative solution. Okay, but anyway, we proceed on this one. Okay, how to calculate the positive ideal solution? The separation distance for the positive ideal solution. The process is, if you look into this maths here, it is square root of summation of alternative value, okay, alternative value minus, if you want to calculate for the positive ideal solution, then you have to minus the positive ideal value. Okay, here I put it positive or negative, right? If you want to calculate for the positive ideal solution, here should be positive ideal value. Positive ideal value is this one. I copy from the previous slide. Okay, positive ideal solution. And where does this number came from? 0.0934. It is from okay. Oops. I hope you can see it. Okay, it is. Oh, I just put it over there. Okay, so 0.0934, it is up here. 0.0934 minus with the positive ideal solution. Positive ideal solution is up here from the previous slide. So 0.0934 minus with 0.1168. And then you square their values. Okay. And plus 0.0366 minus 0.0659. And then you square plus 0.0506 minus 0.0531. Okay, and then you square that again. And then 0.0506 minus 0.0414 square, and then plus this 0.0962 minus 0.1347 square plus 0.2012 minus 0.2012 square. Okay, then finally, please remember that you need to do square root. Then this is your result.
Doctor,
Yes,
it seems the calculation go for
type weight.
only
Huh?
aircraft one only, right?
Yes. Okay. Okay. Before this, the calculation is um, column by column, right? If you notice,
Yes.
if you notice, it is
Hmm.
column by column. But for the separation distance, it is calculated uh, aircraft by aircraft or concept by concept. Okay, clear? For separation distance, the calculation is done concept by concept. First, we do the whole first concept, the speed, range, etc., and then do again for the next aircraft. So later on, what you will get is uh, actually what you will get is S1 plus for S1 plus for this aircraft 1, and then S1 plus for aircraft number 2, and then for aircraft number 3 and aircraft number 4. So you have S1, S2, S3, and S4. 4 value for S plus. And then for the negative ideal solution, uh, you will get another 4 value. Okay.
Doctor,
Yes.
so the alternative is taken from step 4, right? The one that we multiply with the weightage. All right.
Again, I can't get you.
The alternative value
Uh-huh.
is taken from the step 4,
Let
the
me
one that we multiply with the weightage, right?
yeah. From this one. Okay.
Okay. All
Uh,
right.
okay. If you want to calculate the separation distance for the negative, for the negative, so you need to use the negative ideal solution down here. Okay. Just now I show you for the positive S positive. If you want to calculate for S negative, then this is the value that you need to deduct. Like this one, 0.1168 is from the positive ideal solution. But if you want to calculate for the S negative, then you need to base on this value. Okay, yeah. Okay, moving on. Okay, almost done. 8 step. Okay, step number 7, second last step is to calculate the closeness rating. Okay, basically we want to get the final answer lah. Okay, closeness rating. How many percent? Okay, the closeness to ideal solution. Ideal solution means you gain profit at the same time you get away from the risk. Okay, that what does it mean by ideal solution? Okay, for let's say it is for aircraft number 1, I represent the numbers of this one we have 1, 2, 3, 4, right? So I is can be C1, C2, C3, C4. Okay, alternative for each alternative. Okay, where we get these numbers, 0. Okay, this is the formula where you get this uh, S1 negative. S1 negative is this one. Okay. Remember that for the S negative, we have 4 values for each aircraft. Similarly, for the S plus, we have also 4 values. Okay. So for S1, yeah,
Can I ask something about the formula?
yeah.
Why the formula need to square? Mean why and then square root 2? Why cannot just minus the alternative to the negative function? Is it any significant
Okay. Okay.
reason? Any reason?
Yes. There are reasons. Okay. I think that's the one that I forgot to. If you notice just now that I go back and then I didn't found the clue. Okay, this is the things. Why we do the square root and then inside we have a square, right? So what does it mean is we want to, if you just 0.0934, you minus with, it is a small number, and then you minus with a big number, so you end up a negative value inside this bracket. Okay,
Yes, correct.
so we do this square because we want to get rid of the negative value. Yeah, that's the only reason of it. And then of course when you square, of course the total you have to do the square root lah. Otherwise the value might get very big. Okay, that's the idea, to get rid of the negative values.
Hmm.
Okay, clear?
Okay. Okay. Clear.
Okay, then again the process is for C1, alternative 1, for aircraft number 1, uh, to calculate the closeness rating is you take the S1 negative divide by S1 positive plus S1 negative. So this is the things. So this is your answer, 0.6433. Okay. Sorry. Yeah, 0.6433. This one. And if you calculate each of the aircraft, each of the alternative, C1, C2, C3, C4, then you will arrive with this, where you can see that aircraft number 1 is the highest, followed by aircraft number 3, and then aircraft number 4, and the last one is aircraft number 2. Okay, it is uh, more accurate, I would say. It is up to, you can see that up to 3 decimal points. Compare with pure evaluation metrics, this one is more precise in the sense. Okay, I'm not saying that Topsis is better than pure metrics. No. Okay, it is not always the case. Not always the case. Sometimes yes. Okay, it depends case by case, and it's heavily depends also on the value of weightage that you assign. Okay, for the pure metric, normally we didn't assign weightage normally, but you can assign weightage. Normally we didn't assign weightage. We want to have a quick answer, and for any decision, please do both process, the pure matrix, pure evaluation matrix, and Topsis, and then compare your result. Sometimes it is the same, What I mean is the ranking number one is the same. Both agree with the same result. Sometimes it contra each other. So you have to decide. You have to relook into it, whether it is make sense or which one you prefer, and etc.
Doctor,
Yes.
for the step number 7, we to calculate the relative closeness to the oh, okay.
This
To
one.
the yes. The formula is negative. I mean negative over positive plus negative. Not the
Yeah. It is like this. I cannot
Oh,
get this
but
one. It is
because
the inventor of this Topsis have created like this.
oh,
Okay.
because I'm thinking of we are looking for positive ideal solution.
Yeah,
So
yeah,
we
yeah, yeah.
supposed to take the positive one, not the
Mhm.
negative. But this time we take negative.
Yeah. This is how it was presented. Okay.
Oh, okay. All right.
But later on, if you do your PhD or do research, you want to update this formula, yes, you can. You can have a second look on it. No problem. Okay. For our class, we just accept whatever it is. Okay.
Okay, noted.
No problem. I'm more than happy if you want to go deep into it. Okay. So probably we can have a Topsis Azinuddin later on. I don't know. Okay. Okay.
Okay, noted.
Um, Actually, that's all I want to share with you. But I think, yeah, it is the thing that we have gone through just now. The same stuff. There is the Excel file. Have you seen it? Yeah. Okay. So the same steps. Number 2, number 3. Okay. So 4, 5. So positive ID solution, etc. So here is much more representable. So the positive ID solution, I put it in green color. The negative, I put it in red color. So it is the same stuff. And the separation distance, you can see that on that slides, it is only shown as one positive and as one negative, like this one, right? Only show the two values, okay, as one positive and as one negative. But the reality is there are four values, okay, S1, S2, S3, and S4. Same for this one. So, okay, separation distance. There are total 8 values lah. 4 for the positive and another 4 for the negative ID solution. Okay, step number 7, again, like the one that we have gone through just now. We do the this process. Okay, 0.0983 is S1 negative, divided by 0.0546 plus 0.0984 to get this value. And to get this particular value, okay, you can see that this divide by this one plus this one. Okay, this is the formula up here. Okay, and
Doctor,
yes,
along the way, I noticed that all the values are positive, right?
yes,
Until the end.
yes.
They will never be negative in any way, right?
There will be positive as long as you do this process.
Okay.
This one, step number 6.
All right.
Okay, it can be negative values up to step number 5, but on the step number 6, because we do this, this math process, then everything will go to positive value. Okay.
Okay. Even though we have a square root, so we just go for the positive value only, right?
Any negative value, when you square it, it becomes positive. Definitely.
Oh, okay. All right.
Yeah. So now we can rank them. Okay. During exam or during quiz or assignment, the student normally forgot. They only calculate until this point. They didn't put the rank. Which one is number 1, which one number 2, number 3, number 4. So if you didn't put this one, I will deduct some marks. Not much, but I'll still deduct the marks because there is step number 8, which means that you miss one step. Okay. If let's say you have 8 steps, so each step would carry some marks. Okay, normally that is the case. Do I?
Doctor,
Yes.
in certain cases, is it possible to have a same numbers for the closeness rating, which lead to same rank?
Same number, closeness rating. What do you mean?
Yeah, I mean like we might have aircraft number 2 and aircraft number 3 have the same value
Oh, okay.
on step 7. Yeah, I
To
was thinking.
answer your question, I will not answer exactly your question, but I will move to the step number 8. Okay,
Okay.
what happened? What happened? On certain cases, there is a very similar result. For example, for rank number 1, between rank number 1 and rank number 2. For example, like this one is a 0.643 and aircraft number 3 is 0.613, right? So not far. You see, the difference is very close. They are very close. So if this is the case, then go back to your drawing board. Okay. Look again on your weightage, because if you arrive or you get those um, result, it seems that your final result, is not really the best, I would say, because the rank number 1 and rank number 2 having almost the same value, 0.6, and this one also 0.6. So it should be some amount, acceptable amount, to differentiate between number 1 and number 2, number 2 and number 3, number 3 and number 4, etc. Okay. If the differences is very little, then you have to look again what need to be done. Okay. I hope that also answer your question, Zulfaz.
Yeah, so in this case, I can see aircraft number 1 and aircraft number 3 are having quite close
Yes.
differences.
Yeah.
So then we have to look back on our weightage
Yes.
so they can bring the differences. Okay, all right.
Okay, because on the weightage, if we go back, just a second. If we go back to this step number 1 to the step number 1 and step number 2. Okay, are we on the same page right now? Step number 1 and step number 2, right?
Yes, Doctor.
Yeah.
Yes.
Okay. You see that we pick numbers, right? For the average, we put 5, low we put 3, high we put 7, and etc. Sometimes these values would highly impact to your result, end result. Okay, these values might affect your result as well as your this weightage value. Okay, weightage value. Look into the weightage value again, and also this part, the subjective part. Okay, look into these two first. If doesn't make sense, then you need to go further backwards. Okay, look to your QFD again and rating what need to be done. Okay, so that is the process. So any design, we are not going only one cycle. Sometimes, even though you have arrived your destination, you have arrived with these numbers, for example, sometimes it doesn't show the final result. Okay, doesn't show you, give you the final result. So you need to go back to your QFD, even your questionnaire. Okay, so that is the process of design. It might took several iterations. Okay. Okay, enough on that. Okay. I think I'm recording this video, what we have right now. I will upload in the YouTube, and the link I will provide in the Putra Blast. I hope I will do it tonight. And then for this, you have individual tasks as well as a group task. Group task is for your project. Okay, and this one is the individual task. I want you to evaluate the problem of the selection of a personal laptop as given below using Topsis. Okay, this is the problems. Okay, I give you 1 week from now to do this part. Okay, you can do it using calculator, you can use it using Excel or whatever, but I hope whatever tools that you are using, you should understand the process, each of the steps. Okay, these slides that we have discussed tonight, it is already uploaded in the Putra Blast, so you can get it from Putra Blast. You don't have to copy whatever appear on this slide. Okay. It is on the Putra Blast. You can download it. Okay, and then this is your group task. After you have completed your individual task, I may took 2 to 3 days to look into your assignment. This is your assignment. Okay, your assignment to see how you progress, and then I will decide. I will give feedback, of course, and then I will decide our next meeting so that we can have again presentation. Okay, on that particular presentation, you need to I'm looking at these two. Do Topsis, okay, and compare the result with few. If there is differences, then you have to discuss why and prepare a 15 minutes presentation for the next 15 minutes. So I think last time we do a video presentation, right? You record and then you upload it, right? Why don't we use that approach? Okay, we use that approach. So you record, you can record using Zoom, and then you upload it into the uh, Google Drive, or you can share the link like we did before. Okay, I think that's more convenient for us. So you record the video and share the link with everybody, not only me. Share link with everybody. So that is for the group task, and again for the individual task, you are given 1 week from now, not including today. The day is calculated from tomorrow, the next tomorrow. So the due will be next Friday. Okay, I will set the due date is next Friday. So next Friday, 5 p.m. Okay, I will set that. So please do this one. Okay, if you have any problems, please watch the videos, our videos, what we have discussed tonight. The link will be in the Putra Blast. Okay, thank you for your time, and I hope you learned something tonight. Although it is not really straightforward, it is a little bit of complicated, but I hope you can get something out of it. Okay, thank you.
Doctor,
Yes.
before that, I just want to make myself clear. So for the individual task, will be submitted by next Friday,
Yes.
a week. And then for the group tasks, is it going to be another week?
After you have submitted your individual task, let's say
Okay.
Friday, so
All
on
right.
the weekends, on the Saturday and Sunday,
Okay.
I will look into your assignment.
All right.
Then I give feedback.
Okay.
Then from there, I will decide when is the date for your
Group.
video presentation. Normally,
Oh, okay.
normally a few days later.
Okay. So once we have submitted our individual tasks, and if there is any comment or feedback from you, is it possible for us to re-upload the latest version?
Yeah, sure.
Oh,
No problem.
okay. All right.
Just let me know.
Okay, doc.
Yeah.
Okay, doc. All right.
Okay. Anybody want to ask question? Okay.
Prof, the group task, we do a new PowerPoint.
New PowerPoint. You can
Yeah,
add.
since it's
Or is it
related to biometrics.
Yeah, you can add on to the existing PowerPoint, and you can also make it shorter on the things that are not really important. You can take it off, right? Just focus on I think what the main important is starting from the morph matrix, view matrix, and the Topsis. Okay.
Okay, yeah. Thank you.
Okay, thank you. Okay, see
Right,
you
doc. Thank you.
again.
Assalamualaikum.
Salam. Okay, good.